Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before or even considered taking up programming. Today we will look at threads. What are they and how can we use them in PowerBasic? So what is a thread in programming terms? How can I use it and what is it for? Before we delve into the mysteries of threads, we need to look back a little on how computing got where it is today. Not that long ago, computers ran the Windows operating system with a single processing core on one physical CPU chip on the motherboard. Even then, these early machines gave the illusion that they could run multiple programs at the same time, when they were really doing a form of time sharing. Like a timeshare holiday villa, where multiple families can each spend their summer holidays somewhere warm and sunny, as long as they don't all arrive on the same day. These single-core processors operated on the same principle as each program that wanted to be executed received a slice of time on the CPU, and they needed to get into the queue or line to obtain this time to be processed. When the first dual-core processors arrived, the situation improved slightly, as since there were two physical processors, the Windows operating system could run two separate programs, one on each core, at the same time. It was left to Windows itself to handle which applications or programs ran on which processing core. Now that we have CPUs with many more processing cores available, the situation has improved still further, with more and more processing resource available to the Windows operating system. Traditionally, when you create an application, it would run the code on the CPU one part at a time. If you had 5 functions to call, then function number 2 would have to wait for function number 1 to complete before it got the chance to do any processing. Even if your program had a lot of work to do, and you had a multi-core processor, your program would only have the opportunity to run on one processing core. Enter the idea of multi-threading. This concept had been around for many years, but in 2002 it reached desktop processors with the Intel Pentium 4. A thread is like a program within a program that runs concurrently with the main part of the code in your application. This takes advantage of the operating system to spread the load of your processing requirement over multiple processors, and basically gives your application greater access to, and time running on, a CPU. In short, this concept of the thread allows your application to literally do several things at the same time, and it's a big step towards parallel processing. When you amend your code to create a thread in PowerBasic, you are basically building a special kind of function. This thread function takes only a single parameter, which is a 32-bit long, or D word, passed by value. While this might seem limiting, this value can be an ID used to pass process messages back to a dialog the user is watching. Or it can be a pointer to some structure containing data, like a user-defined type, that exists outside of the thread. Once created from your calling routine, the thread will start running and your application will continue on to the next line of code in your calling routine. Of course, you can run many threads at the same time to take advantage of a powerful computer with many processing cores. Background processing. When a user running an application needs things to happen in the background without slowing down other actions that they need to do. Email clients are a perfect example. Your email client lets you create new emails and read received ones, and will at the same time periodically download new incoming emails without interrupting the user. Big data. If, for example, you need to do some processing on a very large data file, and by large we are talking about hundreds of thousands, if not millions of rows of data, then such processes will take time to do. However, if you create a thread function that can be launched 10 times, with each thread handling 10% of the file, then the processing speed will improve considerably. So what terminology do I need to learn? Thread function. This is a function that takes just one by-value parameter. Thread create. This is how you launch a new thread. Thread count. This returns the number of active threads in your application. Thread ID returns the numeric ID of the currently running thread. Thread status. This will return the status of your specified thread. Is the thread running or has it completed? Thread close. This is used to free up the memory and CPU resources once the thread has completed. Thread set priority. This is used to set the Windows priority of a thread. Just like the application priority, this can range from idle, as being the lowest, to time critical, being the highest. A thread which has set its priority at priority idle means that it will only be executed when there is very low usage of the CPU. Obviously, it's recommended to run your threads at normal priority or below. Running them above that priority does actually take a lot of the CPU resource away from other Windows processes. Thread get priority. This is used to get the priority of your thread. You can use this to determine what priority you've currently set for the thread and then decide whether you wish to raise or lower the priority. So when should I use threads? If your application has the need to deal with large volumes of data, threads can be a way to speed up your processing. On a system with 4 processing cores, having 2 threads can halve the time taken to process, depending on the task. Running 10 threads on the same system will not though process in 10% of the time, as Windows only has 4 cores to run processes on and there will be contention. So choose your thread count wisely. If your application has a user-facing dialog and you don't want it to display the application not responding type of message, when it is actually processing some background task, it's time to consider adding threads. I'll put a link in the description below to a simple example of PowerBasic thread handling. But that's it for today. Thank you for watching.